Alright, with problem number 5, for which of the following values of k does the equation x to the fourth minus 4x squared plus x plus k equals 0 have 4 distinct real roots? And I think what you should take away from this problem, first of all, is understanding that whatever the degree of a polynomial is, it potentially has that many real roots. And the second thing is that the constant k that we have in any polynomial always affects the polynomials the same way. It affects the vertical translation of the function. So if I were to graph this function with no value of k in there, or with k is equal to 0, then I would have x to the fourth minus 4x squared plus x. And if I zoom standard and see what that looks like, you notice that I have 1, possibly 2, and then 3 roots in this particular one. So what I'm going to do is I'm just going to plug in the 3 different values that I have and look to see which one of them gives me 4 distinct real roots. So I go back to the function definition, and this time I'm going to put in minus 2 and go over and graph that. And you can see that that only gives me 2 real roots. So that one is out. This time I'm going to put in plus 1 and graph that. And I can see that that one does give me 4 real roots. 1, 2, 3, 4. A root is a 0. That means where the function would equal 0, where y is equal to 0. That's what a root, a real root is. A real root has to cross the x-axis. That's also known as an x-intercept. Roots, x-intercepts, y equals 0, and zeros all mean the same thing. So we know that number 2 is good. Let's try out number 3, where we plug in plus 3 at the end. We go to graph that, and we see that that one has apparently only 2 real roots. So the real answer for this is only number 2, so the answer would be A in this particular case. Okay, so that's really all you need for this particular problem. You want to understand what zeros mean. Again, those are x-intercepts, y equals 0. We call them roots as well. And the second thing is that k has to do with a vertical translation. The constant value that we add or subtract from a function, from a polynomial function, only affects the vertical translation, moving the function up and down. And you can see that by doing that, we're going to get somewhere between 0 and 4 real roots for every fourth degree polynomial function. Okay, so we're going to stop this at this point then.